So last video of the day, YouTube, my YouTube account shows there's no views on any of my videos. Well, there's a few views on a couple of them, but which is wrong because I've actually had people ask me for the link to some of these videos so they could watch them, and then I give them the link on Facebook and they watch them. And they tell me they watch them and they don't show up as views, so they don't watch the whole thing. Something goes on there, but I know that an engine swap on my parents' lawnmower, I did have permission. I've got recordings of that permission. As I showed you guys earlier, anytime I do something, I record it. I actually took videos of when I was working on the tractor. He gave me the go ahead to pull it apart because the gears were, not the gears, but the bearings to the gears were grinding. So I was looking at some videos and people were putting larger pulleys on the front engine pulley on lawnmowers and smaller pulleys on the transmission to get a little gear amplification or pulley amplification to the rear transmission, which they went from like 5 miles an hour to 11 miles an hour. There's still gear reduction in the transmission on a lawnmower. And if there wasn't, you would take off with about 2,500 RPMs if you had the power to pull it, which you probably won't. And it would be a ridiculously insane hold on to your fucking shorts ride, and you would probably shit yourself along the way. Your average lawnmower engine, I'm sure it might actually have the power to pull itself without gear reduction. It would be insanely fast, and you know, that is a small, I mean, it's a rather small engine. It probably wouldn't have enough power to go with you on it. It would probably stall. It's kind of like trying to take off in your car in 5th gear. It's a no-go. And that's how mechanical power works, is through gear reduction. So even if you do swaps like that, even some guys will do gear swaps in their truck to get more speed out of their trucks, and they'll achieve it, but they won't have the power that they had. They won't be able to pull as much. I guarantee you, if you do a 3-time pulley amplification on your mower and you go 3 times faster, if you hook a trailer to your mower, you're not going to be as able to pull as much weight. Plus, they're not designed to go that fast. So it's kind of the same idea with the gear amplification and gear reduction on the hydraulic car. The transmission is definitely going to be far more gear reduced, or the gearbox is going to be far more gear reduced than the amplification on the hydraulic motors, which is that way for a reason. That way it'll have the extra power to have a more instantaneous reaction, and pretty well that's kind of the idea of it. Plus, with the gear amplification, I'm wanting to find a number that is just right, where I'll have good reaction time out of the hydraulics, and I will not have so far of a leap to stabilize the vehicle. Basically, when it's in the air and you're wanting to keep it level, you don't want to have to slow down your hydraulic fluid so much, because if I bypass that fluid, it's going to start losing power the more fluid I have to bypass. So if I have to, the less fluid that I have to bypass to achieve stabilization is going to be the better. Basically, if I have to bypass half the hydraulic pressure to slow down the engine speed half. That's also going to be half power. So what the idea is with the gear amplification is, instead of having to do it half, having to do it a quarter to slow it down, half, or even less than that, to where when I go to redistribute the hydraulic fluid, it does not lose power because I'm redistributing more hydraulic fluid to slow down the propeller speeds, 500 to 600 RPMs, or if I need to slow down the propeller speed 1,000 RPMs. It's not going to require me to cut so much hydraulic fluid transfer that I'm going to lose half my power. It's literally going to be so I can send a little bit of it off into a bypass or redirectional line to where it will only require a little bit of that and not a lot of that. Because if you get too much hydraulic fluid not being pumped into the same line, it is going to lose power slowly. So that is part of the reason why I started looking at gear amplification on the hydraulic motors, is so there won't be as much of a need to transfer as much energy by bypassing more hydraulic fluid. The less the better. Plus, hydraulic motors seem to have a it's not going to be exactly an extremely slow reaction time, but there is a small lapse, and the smaller the interval you have to go, the faster it's actually going to react. So that is why I'm kind of playing with the gear reduction and gear amplification and things like that, because even so, there's going to be a free spin in the propellers, which is why there's a ring all the way around the propellers and a brake piston on the outside of the propeller within the encasing of the propeller, to where when those speed reduces do need to be made, one, you don't have to redirect that much fluid, and two, the brake will definitely help it slow down a lot quicker. They do not have that much of a reaction time problem speeding up, but it still takes a few seconds, so that'll also reduce the time between when it needs to stabilize and when it reacts. The less the better. The less I have to change how much fluid goes through that pipe, the better. The best thing would be for it to be constant, but that's really not possible, needing flight stabilization. So what I'm going to have to rely on is gear amplification. That way it does not have to redirect as much fluid movement to where it will not lose hydraulic power as you're trying to speed and slow down the engines. And that is also why I basically did a clutch delete on the drawings. And I'll show that here in a little bit. I basically did a clutch delete on the drawings and went with a piston type hydraulic thruster, where it'll basically move a piston from one hole to the other. And when you first started and engaged the clutch, it's not a clutch delete, but it's not going to be to where when you push in the clutch it's going to take off. It's going to be to where you push in the clutch and it starts cycling hydraulic fluid back and forth from the motor, and then as you move the thrusters forward, it will redistribute that hydraulic fluid into the hydraulic motors and into the lines for the motors, and then the rest will be done with basically the magnetic flow control valves, is what I call them. And I've already actually got drawings from months ago where I already basically designed where it would be an H pipe, or it would be a line flowing all the way back to a separate line flowing all the way back to the reservoir, and completely bypass the return line completely. And that is from months ago. I'll dig it out, I'll show you. So yeah, I've already kind of got all these different drawings of ideas that I've had, and I do believe I actually am going to have to redirect that into a totally separate line and not do the H pipe, because I'm either going to have to do the H pipe at an angle to where the fluid that comes through will be going the same direction as the fluid going back to the reservoir, and that they'll meet and not want to do this mixed swirly kind of thing, or I'm going to have a separate line altogether, which I have both of those covered in the originals that I was drawing in the month of January. So those are those. But yeah, I have several separate drawings and photos of all of these drawings. So yes, it's not something that someone's going to be able to put a line on or something like that and just be able to go, oh well, it's mine now. It's definitely something that I've pretty well covered every avenue. You know, when I did the deal, I put 4, 6, and 8 wings, or 8 propellers, 4, 6, and 8 propellers. There was also probably a week after I started in on this, I started drawing up ways of redirecting fluid that wasn't being used to a totally separate line. That's in there. That was probably the second week of January when I drew that. And then there are other drawings as well. But yes, that's definitely why I'm playing with the gear reduction from the pump to the engine. That way it'll have the power to pump the fluid. And that's why I'm definitely playing with the gear amplification on the hydraulic motors. That way it won't require nearly as much fluid change, or as much of a change in the fluid motion or transfer to achieve flight stability. So definitely something I'm working on there. You know, I'm sure once I get it patented and they start designing it, there'll be a lot of testing that they have to do and stuff like that. But we'll cross that bridge when we get there.